why don't you turn around and let them get a view from there, and see what the field view looks like. The document for the quantity going around. I'm not let them get a view from there. I'll do what the field is outside. The documents are still up.
Portable network. Shall I turn it on? Is this on? Is it working now? So, can you hear me? So when you switch, you can just give it to Chris, Richard and Chris. Yeah, so whatever you switch, so just give it to the next person. So what we're going to do, we're going to just take you through some of the stages that the company has gone through. I will briefly explain about the company background. I'm sure a lot of you already know what we've been doing. Then Richard, our CTO, would explain the business case and some specific uniqueness of our approach towards the advanced air mobility, and Chris Gear, our Chief Program Advisor, would talk about the program and the strategic environmental strategy that we have taken on. For those of you that I haven't introduced myself, Sayed Mohseni, CEO and founder of Aerosystems. Whoever feels tired, please, we have few seats. We have a few seats for seniors and non-seniors, so don't worry. I set up a company in Cranfield, as you can see, just next door, Aerospace, back in 2017, with the idea of developing vertical takeoff and landing aircraft with electric propulsion. So we started with the strategy of designing and building scale prototypes of the concept that we were suggesting in the beginning, which was the concept of the E-Starling, and build a team around it. So the company runs 15 full-time individuals, and 6 are part-times, and also a group of 50 contractors that they work on various projects with us. If we step back a little bit and look at the world view, we have in the world we have the energy trilemma problem across different industries. Like we have the security of the supply, the affordability of the energy, especially during the last few years that everybody is feeling it. Also the sustainability aspect. And this trilemma also reflects itself in the aerospace industry. In specific terms within the aerospace, I think, and I think with the group of our senior members, we believe that it trickles down to some key areas of propulsion system, new novel design of aircraft, but also the operational business cases. That includes infrastructure and social acceptance, various aspects related to market and regulation. So has been in different way reflected in the Aerospace Technology Institute strategy, probably in different wording. So we managed to bring together a very impressive group of professionals from the UK industry, probably some of the best ones. And I believe that the group that we have, they have all of the relevant expertise and track record to deliver what we want to provide to the market. So as I said, the company we started very small. Probably was just a desk bigger than this in 2017, but gradually we brought people in and designed scaled prototypes. We flew that aircraft that you see on your right hand side is the almost full-size prototype of the C-150 UAV, 150 kilogram aircraft with a capability of about 25 kilogram of payload. So it will fall into a category B UAV. And so this is going to be one of our products going forward for the light deliveries. Then we move to the bigger aircraft of we call it an R&D S5. This was S5U and that was S5M. The product is part of the C series of a 600 kilogram aircraft. We flew the CTOL and then the VTOL, and that's going to continue for both VLOS demonstration and also BVLOS. The company has been supported through various means of the grants, loans, and equity investments from UK government, overseas investors, the UK investors, and some of the investment from the founders as well. So the three products that we have been focusing on, two of them on the unmanned side, and the uncrewed aircraft has very significant opportunity for the cargo application and express deliveries. But we also believe that, and we can see that there are certain challenges related to the certification of this type of aircraft, and our approach is that we would take on very simple use cases in the beginning for this aircraft to operate, that allows the regulator to support us. Then gradually, as we build more flight hours, then we can add the more complex use cases as well. So the C600, you see the aircraft, the big aircraft on the right, is the largest VTOL UAV in Europe so far. We're going to continue on the program. Then the Lynx, which I will explain the rationale behind the Lynx program as a rotorcraft. So when we wanted to move to the passenger aircraft design, following the E-Sterling, which was these two aircraft on the side, this was the E-Sterling program, and we wanted to get into the passenger preliminary design. So we got together a group of professionals. Some of the senior members also helped to assess the overall journey that we have to go through. And what we found out is there were some very serious showstoppers from a business perspective. The most important one to be the certification aspect. So any aircraft in the world now wants to be certified under EASA or FAA, has to go through a very stringent certification program that is kind of also not known completely. There are some suggestions on the CSV tool, which requires the aircraft to be certified almost at the level of a commercial airliner. That makes the certification program very long, but also extremely expensive. It will push it to values of around sort of $1.5 to $2 billion. And so to certify a 4-seater aircraft with a $2 billion investment, it just doesn't make sense from a financial point of view as a business. So we thought, what can we do to deliver what market wants, which Richard would explain about the market in a minute, and at the same time achieve the targets of the affordability, both for the consumers or the people who are using the aircraft, and also the company. And the conclusion was, we have to go single rotor. FAA is telling us there are special category of powered lift that all of the advanced air mobility companies, they have to go through. And so to avoid that also, we said that the rotor has to be unpowered. And we were lucky enough to find the world's only commercial gyroplane that was certified back in the 60s in Canada, the aircraft that is behind you, that has the jump, takeoff, and no-roll landing capability, and it is certified under Part 27. So we managed to acquire the IP, and we just received the aircraft last week. That's why it's not been reassembled again. But it's very impressive piece of technology that has allowed these type of aircraft to fly from a helipad. So the flight characteristics are not exactly the same as helicopter, because this aircraft is not a helicopter, but it has the capability of helicopters apart from hovering. And our market of advanced air mobility doesn't really require us for hovering. And hovering is extremely power consuming, especially for some of our competitors. So what you see at the bottom left blue corner, the difference between a distributed propulsion system on the aircraft, in this case is the aircraft that is being developed in Germany, Lilium, that requires the power that is required for takeoff of a small scale aircraft. They had a 640 kilogram one, and they would require 237 kilowatts of power to take off. And we understand that because we have our own multi-rotor as well. We know that it's a very power-hungry stage. If you have a single rotor powered on the ground to provide the lift element, that comes down to 32. And so it's a significant effect, and that effect is because of the disk loading. The amount of air that we can move relative to the area that we have. And high disk loading means you need a lot of power. That means you need a lot of electric motors. In this case, this particular company, they have 30 electric motors. Electric motors mean extra weight, extra cable, extra heat exchanger, extra complex systems, and you end up with a certification roadmap that is, for some of the professionals, they can't even see the end of it. We had these type of problems in AW 609 certification program, that even a big company like Leonardo took now close to 2 decades to certify. So that was the rationale that we moved away from the multi-rotor. We were lucky that our investors were very much understanding, and they understood why we have to move away. And in a way, it gave us a very good competitive advantage in this market to avoid the CS VTOL certification and FAA relevant FAA certification path, to move to an aircraft that now, because of the low disk loading, allows us less systems to go on, and therefore we have more payload capability to transport 9 passengers. And this is the largest air taxi in the world, purely because of that reason. So Richard will take you through the technology and the market on the business case side, and then later on Chris will talk about the environmental aspect. But any questions so far? Please, just shout out. It's not a monologue on our side. Thank you, Richard. Yeah, I think you need this here.
Okay. Hello, my name is Richard Abbott. I'm fortunate to be the CTO for ARC. I'm the only person wearing jeans here today. Syed said to come business casual. I've been living in North America for 20 years, so to me that's shorts and flip-flops. So jeans is really dressing up, to be honest. So I'm fortunate to be the CTO. I'm fortunate to work with the team we have here, Cheyenne and Norman, and Skip and Fareed and Farah and everybody. It's a great team. I'm fortunate that we have a board of advisors who are older than me and know more than I do. I've got an age where I'm brought into programs, and I'm the oldest guy on the program. And so it's a real benefit to not be the oldest guy on the program and to have people challenge me. So let's get into the meat of what I'm talking about. If you want to know whether you have a market, ask an engineer, because we don't care about people's ideologies and preconceptions. And I've also missed the titles of these graphs on purpose. You'll have noticed that. And so here's a question, and Pietros can't answer because we went through this yesterday. Does anyone know what this top graph is and what happened in 1980? Anybody? Norman. Okay, Norman, you tell us, what is it? Okay. So this is general aviation, and this is the state of global general aviation. So the top graph is the number of shipments of aircraft in the general aviation class per year from 1949 to 2017. This data is freely available. You can talk to GAMA, the General Aviation Manufacturers Association. They're the caretakers of this data. And what happened in 1980? Well, something really bad happened. They changed the law in the US to change product liability. And manufacturers stopped making aircraft. Right? And that's interesting, isn't it? Because that's 43 years ago. There was a drop from, I was just going to say that, 18,000 per year in 1979 to an average of around 2,000 a year since. Right? Good data. So the lower graph is if you take these numbers, and I've assumed an average of 2,000 per year from now and on, and you give each aircraft in that fleet a 60-year lifespan before it lifes out or has an incident or corrodes or fatigues out. This is the number of aircraft in service. This is 2020. This is 2040. And that gap is 200,000 aircraft, right? No one knows about this, or at least no one that I've talked to knows about this. I mean, there's me and Norman now, and a few people here. So what does that mean? Well, it means if we have a one-for-one replacement over the next 20 years, we're going to need about 100,000 aircraft. Now, maybe that's optimistic. Sorry, 200,000 aircraft. The numbers are so large, and the market is so unimaginable. You can get it wrong. So let's say it's half that number, 100,000 aircraft. Well, how do current manufacturers meet that need? Well, they don't. So there's two of the leading examples in the general aviation field here. There's the new boy, 40 years old, Cessna Caravan, designed for FedEx, has a pretty short range, about 600 nautical miles at best. Useful load's good. They've made 4,000 aircraft over 40 years. At their peak, they were making 200 per year, right? And there's about 3,200 still flying. FedEx still fly a fleet of around 230 of those under third-party operators. That's a popular plane. But can they make 200,000 of those over the next 20 years? No, they aren't going to do that. The Twin Otter, 60 years old. It was made from 1966 up to the late 70s. Production was restarted in 2008, 2007 by Viking Air out of British Columbia. There's how many flying? 985 were made. There's probably around 700 still flying. They're making single digits per year. So what we have is an unfathomably large market opportunity. Now, why don't we see this? Well, because there's nothing there to replace these aircraft. So I've talked with operators across North America, and they are keeping these things flying through modifications, upgrades. Icana, right? You needn't buy a new Twin Otter from Viking. You can go to Icana with a second-hand Twin Otter. They'll charge you $10 million, and they'll re-life it back to zero life by replacing the wing spars and replacing half the fuselage. That's how much these aircraft are wanted to be in service. And this is why I'm fortunate to work here, because we've moved from the eVTOL space into a space where we can start to meet that market need. All we have to do is be better than a reconditioned 60-year-old airframe. That's a pretty low bar. And so we can do that. It's not hard. So these graphs do have titles, much better. So these are what we use for performance comparisons. You can see them in brochures for new aircraft. These are what are called payload range diagrams. So the payload is on vertical axis, the range is on the horizontal axis. This is good, and this is good. This end is bad, roughly. Right? So we're the green line. So the top graph is comparing us to twin-engine rotorcraft. And at similar weight, so we're 7,000 pounds, to stay within the Part 27 limitations. And we can fly twice the distance at 50 knots faster than any rotorcraft out there. Good, right? That makes us look good. And these are twin-engine fixed-wing aircraft. Now, we're not quite as good as those, because we're twin-engine, but we're carrying the weight of a rotor. And we're limited to 7,000 pound gross weights, and there's some 8,000 and 9,000 pound aircraft in here. But we're pretty competitive with, well, what we do have there, we've got the Tecnam P-2012, the Piper Navajo, the Cessna 402, which are all flying in cargo fleets around the world right now. And they can't take off or land vertically. We can. So the best way, when you think of something brand new and really exciting and innovative, how do you mitigate your technical risk? Well, you find someone who's done it before you, and you buy the program, which is what we did. We had, I'm very fortunate to work here because this company has a lot of luck as well. So the dirty secret is that we planned this to be analogous to the fairy rotodyne. If you know what that is, it was a failed UK project from the 1950s. It never got certified. It was incredibly loud. It got a bad reputation. And we thought it was a really good idea and could be really improved upon with modern materials at drivetrain. But it wasn't a success, and it was never certified. And then we were talking about this, and Syed found this project online. And he put an offer in, and he bought it, and it's exactly what we wanted. So we're fortunate that we now have this. Now what this gives us is something anyone else with a brand new idea can never have. We have almost all of our technical risks fully mitigated. We have almost all of our certification risks fully mitigated. I'm fortunate to work here, right? 'Cause my job's a lot easier now. Now my background, my sordid history is I've been working for 20 years in North America, 10 years in the UK before that. I've worked with over 100 aerospace startup companies, and they have all failed. And that's not just because of me. There's a whole load of reasons why they fail. Typically, they will get into certification, and they won't get out of certification, and that means bankruptcy. Or they will get into certification, they'll get out of certification, and they've pre-sold aircraft. And the reason why you pre-sold aircraft is to raise the money, but they pre-sold them too cheap to sell too many aircraft. And by the time they get out of certification and they get into production, the cost of producing the aircraft is greater than the price that they've contracted to their customers. And you lose money on each and every aircraft. Icon are doing that right now in the US. Sarno Swearingen failed because of that. Eclipse failed because of that. Right? And so these companies almost never succeed. So the trick is to learn from other people's mistakes. And I have a catalog of those, and that's most of the value that I bring, is that we know all the mistakes to avoid. We've avoided a bunch of technical mistakes because we paid for all the mistakes someone else has made and fixed for us.
You have a video of this, maybe we can play it now. Yeah, this one.
Sure.
That's the one of the flight demonstration of that aircraft. It's pretty old, obviously, but it tells us.
Ah, yes.
It shows how the aircraft flies, and that's how it doesn't need a runway.
So this is the Pegasus. It's a really fascinating aircraft. There's some really clever things about it. Some things we don't use. You'll notice there's a big circular duct around the fan on the back. That acts as both the horizontal stabilizer and the vertical stabilizer. It's what's called an annular wing, but it's also a duct that increases propeller performance. We're not using that because we're twin engines, so that wasn't an option for us. But it just shows how smart these guys were.
But this rotor was not obviously powered, so.
Yeah. So it flies like a regular gyroplane or a helicopter, and we'll see some. I think there's a no-roll landing shown on this, so we'll see it coming and land.
It says zeros forward speed landing.
Yeah, and it was certified for this operation. So our aim is to be what's called a Category A Class 1 rotorcraft. That'll put us in direct competition with the leading rotorcrafts. The AW109 is one of the markets we can pursue. We can pursue any light rotorcraft market. We can pursue any light fixed-wing twin-engine market. We have a lot of opportunity here. If you have any questions, I'll be very happy to field them. If not, I will hand off to Chris Gear. Chris!
mentioned the volumes of very valuable data that also came to the intellectual property.
That's true. There's a vault, back in the office, which is a locked room, which has all of the documentation for the certification, design, analysis, and compliance work for that project, which for us is a gold mine. It's a roadmap through the certification process. So we know that we can come out the other side without going bankrupt, which is really important. And eVTOL seem to have missed that key aspect of company operation so far. We'll see what happens. I know what my money's on. Thank you.
Right, so you're now with the senior member, according to Richard. What I want to talk to you about is why am I here, actually? Because some of you might say, I was the CTO for GKN Aerospace for many years, and therefore I have a lot of technical knowledge and everything. But why I'm here is because I met that fellow over there called Glenn, and I met Syed, and I thought they were ringing me up to talk about eVTOLs, and I was going to tell them I'm not interested. And what they talked to me about was something called the links. And the reason I'm interested is because this is a unique capability in this vehicle to take off in a very short distance. And the first question I asked them is, does it work? Because aerodynamically, if you think about it, you've got a big rotor, propellers. Does it actually jump up and then fly away? And the real clincher for me was the vehicle that's behind us here. Because in the data packs that came with that vehicle, they have actually shown all the lift coefficient and fly-away conditions, and so truly validated this works. So the problem with that vehicle, it's 60 years too old. And so what we have now is a unique opportunity to develop a vehicle based on technologies today, which are absolutely going to help this vehicle. So the rotor being driven by an electric motor is going to be a significant benefit in weight, but also performance. And then we have those twin engine pusher engines where we have the ability to take today an existing certified engine to prove the concept and then swap that out for an electric motor or a fuel cell or some of the greener types of energies that are available. And I think that's the other unique opportunity we have here. The other thing to think about is a lot of the eVTOLs that you see out there, including these ones in the room, battery powered, their ranges are very limited and their capacity. So they might carry 4, maybe 5 people, but they're only going to do 100 miles or 150 miles. When you look at the cost per mile that's going to generate, they're going to be very expensive. So it's only going to be a unique group of people who can really use those, mainly business people. With this vehicle, we're looking at it can help communities. It can easily take off in a football field, in fact, shorter than a football field, and fly between small towns on football fields. So it has some capability, which there is plenty of opportunity and market there. It's actually trying to promote that idea and get people thinking about how would you apply this. And so I think that's one of the key things about this. Now, being senior, no one told me how I paged down, is it? There you go. So what I'm going to talk to you about is, as well as my experience at GKN Aerospace, I was actually the program director on a program called Fly Zero that was funded by the Aerospace Technology Institute. In fact, one of my chief engineers is here, so thanks, David. And also by Bayes. And what we looked at was liquid hydrogen powered commercial aircraft. We looked at 3 different ranges. And we learned a lot of information about what the capability is today. And one of the limitations of liquid hydrogen today is the infrastructure doesn't exist in this country, in fact, in the world, to build and make enough of it, cheap enough that want to make people use it. But we proved that in 2035, 2040, the capacity will improve and that capability will be available. But the problem is that's probably only going to be available in Europe, because the US are very much focused on sustainable fuels today, and they have a lot of infrastructure and industry working on that. Boeing hasn't quite committed to hydrogen. Airbus, as you all know, is working on hydrogen. So there's going to be a mixed solution going on. So what we see is the benefits is, by 2050, you could definitely have liquid hydrogen running in an aircraft like this. But today, we could use sustainable fuels, so we can use, fuels from agriculture or plantation fuels, so we can reduce some of our CO2 emissions. But again, being lateral thinking, there's liquid natural gas, which produces less CO2, which could be an option for our aircraft. So again, there's another option here. But what we want to try and do, first of all, is to help us prove this concept, is to make an E2 aircraft. So I'll call it an E2 configured aircraft. So two-seater, similar weight to the Pegasus that's behind us. So we can actually prove all those lift curves and everything, but also we can prove the concept of our twin engine pusher arrangement. And by doing that, it'll allow us to come up with a sustainable solution and also look at sustainable engines and fuels. So we have a unique opportunity to swap a lot of our engines and fuels around as we need to meet the market needs and meet sustainability. And a lot of the subjects around urban planning and that, which don't exist today, would then need to be developed to help our aircraft. So that's our thoughts. And so we really see, how do we get this aircraft into the marketplace? And as you know, we've got 3 aircraft. So there's the 150 kilogram aircraft, which exists today. We just need to productionize it, and it would be available. It doesn't need type certificate. There's the 600 aircraft that's over there on the left, which is a 600 kilogram aircraft. That will need type certification if we want to get that flying. So that is available by 2025. But really, the one at the bottom here is the one that I'm talking about. And we really need to look at how we can develop the technology, which can be quite low grade, to be honest with you. To begin with, we can use existing technologies. Electric motors are very robust and stable today. We maybe need one new joint between the rotor and the electric motor, but the rest of that infrastructure over there could be standard aircraft equipment that you can easily buy off the shelf today. And therefore, we can quickly get to a certified viable condition and then evolve that into what the future might be, which we see as a complete carbon fiber structure. As you can see, the landing gear fold away, and we can see the range of this could be up to 500 to 800 nautical miles. So incredibly different than what an electric eVTOL could do, and can seat 9 people. So we see that as the potential, and we're targeting to have a TC by the middle of 2027, and looking at flight conditions sort of happening in end of 2025. So those are the big challenges ARC have today, is actually getting to that position where they could have something flying. It's not impossible, but it will be a challenge. And just to show, to do that, we need to get on a certification roadmap with the links. And we've actually spoken to the CAA now, and we've now got a position of understanding around the CS27 standards for helicopters that can be applied to here. So that is really where we're targeting to go now. So that's really what I'm going to say today. Do you want to put the last slide on for yourself, or should I put it up for you, Syed?
I think that's about it, yeah.
Okay.
Yeah, very good. Thank you very much.
Okay, thank you. You want to finish off there's a couple of other slides if you...
Thanks very much. Thank you, Richard. Thank you, Chris. It just a couple of further slides. That's a good news that we have recently received. So we are here in Cranfield Technology Park. That's Cranfield Airport, that's Cranfield University. And we were again fortunate that we found a land just next to the runway in Cranfield. We managed to acquire the land, and we applied for a planning permission for a technology center for ARC Aerosystems, which includes 2 buildings. One is the R&D building that we're planning to have our core design DOA team in there, and the ancillary building that supports that development. It's more of a sort of the center of excellence and the R&D center. Yeah, this was actually, we got the planning permission. When was John? Was it Thursday? Wednesday. Okay. Yeah. Yeah, it was. We had a unanimous vote in support of this development. Yeah, we are quite pleased with that. But any question you want to say, in front of everybody, or any of us, please, come and talk to us. The purpose of this gathering, partly to inform you about the program, about what are the benefits of this program, and you can think obviously at how this would fit your strategy and how we might be able to work together, or you might know some people that they would be interested to look at this program. It's a UK-centric project, and it's a viable project that, in a way, brings the capability that was lost in UK back. As Glenn sometimes says, this is a back to future approach. We'll have lunch together in about 15 minutes, but thank you for listening. It was great to see you guys. Thank you. That's true. Yes. Yeah. So we have an operational cost model that we have been working with some of the operators to make it clear in a way, because affordability was one of the key aspects of this. We didn't want this aircraft to be just for rich. This aircraft is to serve communities. This is to connect the communities. The reason that the name links come from is to link remote communities to the centers of economy, because now we are doing a lot of work in Scotland, and we see a lot of remote communities, and the population of the remote communities are dwindling, and people are moving to cities because there is not enough opportunity there. If we provide the transport infrastructure through this aircraft, then we allow them to stay where they are and prosper where they are. So it's a project that serves the society and the community from that aspect, while it is sustainable, and also helps the governments to keep people where they are. And the case of the leveling up strategies, it provides that social benefit to everybody, rather than just a small group of people. Because you probably know the people are not that much keen on helicopters. Primarily is because they are expensive, so they can't use it. If they can't use it, just a small group of people can use it, and they would not be happy that they will have the noise of helicopter flying over the towns. They probably would be more forgiving for helicopter to run for ambulance, or a little bit better for the police forces. But beyond that, it's a difficult one. Whereas this aircraft is a 21st century air transport infrastructure. We don't see Lynx as another product similar to others. We see this as part of an air transport network. We are working in Future Flight Challenge. We are conducting a feasibility study to design and build 100 vertiports across Scotland. This network, including 250 aircraft of Lynx, provides opportunity to transport 25,000 people per day at a cost that is 20% of the cost of the rail transport, at least 20%. So when governments even look at this, they have a rail project and they are spending billions and billions every year. This is faster to deploy, it's significantly cheaper, and it's also environment friendly, and it saves a lot of time for people. Now, in Scotland, we have realized that you can almost guarantee the time of the travel for people. You can go anywhere in Scotland within a day. And that's very long, currently. But with Lynx P9 and our proposed network, you can go anywhere in Scotland within an hour. And that makes a massive difference. So Scotland is just a platform to demonstrate how this works. And then there are a lot of places around the world, like in Alaska, in North America, in a lot of places in Canada, in India, in Southeast Asia, that they have a lot of islands, and the transport links are not in place, and governments are struggling to invest on the transport. So on your question related to the operational cost, the model tells us that with an assumption that the aircraft would run about 2,000 hours a year, which is for a commuter type approach. The cost is about £800, the total operational cost per hour. And what we think the operators, they can probably charge about £100 for a 100-mile journey. So £1 per seat mile is achievable. Whereas the competitors of advanced air mobility, that they are using electric propulsion systems and multi-rotors, their minimum quoted figures is £2 and above. And helicopters, you probably know better, sort of £4 plus. So that's in a way better than what exists in the helicopter world. Yeah. Good. Very good. Thank you.
You're comparing with the rail, you said.
Pardon?
You compare with the rail transportation.
Yes. So for the case of
It's cheaper than that, isn't it?
to set up is expensive.
Yeah.
Let me give you an example. We did a study on Oxford to Cambridge, and you'll be surprised how long does it take to go from Oxford to Cambridge? 2.5 hours. It's just 60 miles journey. But it takes 2.5 hours. So there is a project that in ARC, as is our region, the Cambridge and Oxford ARC, the feasibility study for a rail project is a 100-mile rail track would cost £5 billion to do. Yeah, so £5 billion to just set it up. All of the environmental damage that they cause to set up the rail, and all of the CO2 emission as a result of producing, all of the rails and tracks and so on, is significant. The amount of cement and beton that they require to consume. So it's environmentally damaging, and also from cost point of view. The same number of people could be transported using links with a network of, we did this study of 10 vertiports around Cambridge and 10 vertiports around Oxford. And they can transport 10,000 people per day on a commuter type approach at a cost that is, even on the operational side, is competitive. And it's, pardon?
Investment.
Pardon?
Without the investment, only the price.
Yeah, the investment would be 20% of the rail investment. So there would be still obviously investment for build of the vertiports and the aircrafts themselves, but it's about £1 billion rather than £5 billion. And this becomes significantly more in the difficult terrain similar to Scotland. So there are certain areas in Scotland that would cost £100 million per mile of rail tracks and setting up just for that. And so the returns on investments are so long that generally the private investors that would not be interested in that, and would be sort of investment from governments that they would have to lay it in because of the society aspect. So I guess it's one of those things that, for example, a country like India, that they have existing rails, but they are poor, in a poor situation. There are a lot of remote areas that the aircraft can provide the service, and it's fairly quick. It doesn't take decades to set those operations. Similar to what happened in India for mobile, because when mobile came, they just ditched the cable telephone and just used mobile, and this is very similar in that sense. Very good.
I think the other aspect is the infrastructure investment compared to especially the electric install.
Yeah, absolutely. Yeah, I was at eBay giving a talk and a couple of panels, and one of the guys who were sharing the panel with me was a gentleman, the director of a company called Bayard in Netherlands, and they're designing and building vertiports. And they were saying, interestingly enough, that they've gone through the planning permission and they still don't have firefighting regulation for the electric aircraft. And they said that the latest one that is available is in the automotive industry, where the UK firefighting agency has proposed to put a massive water tank, and if the car catches fire, the battery catches fire, they have to put the car submerged in the water. That's the only solution that they have provided. Now, what can we do with the aircraft? They didn't have any. So there's a lot of problem, not just on the cost of the infrastructure, which is expensive, but also the safety aspect of that. Now, when we wanted to develop our vision, I remember Glenn was saying that, you know, what if we can take off and land from a football pitch? Because every village has a football pitch. It depends obviously which country you are, but it's, so you can imagine that with a strip of land, this aircraft would be able to, you know, take off and land. So if we make it as infrastructure agnostic as possible, then the deployment becomes easier case. So for those of you who are aware of the dynamics of the eVTOL advanced air mobility, you can see that there are people coming up and saying, are we not you know, pushing this too soon, or are we ready for it? Is the infrastructure there for us to use? I mean, apart from the certification, which is a big hurdle. So if, you know, somebody like Joby, they have $1 billion cash, and they probably would have a, you know, massive contract from you know, Army in US to push this through. But where is the infrastructure? And then at the end of the day, the key thing is the value to the society. What value we are giving for people who are you know, knowledgeable in the insight of flight. If you study, you will conclude that it's better to reduce the flight. Generally, flying is polluting. Now, we are not, as a company, we won't promote flying. We say fly in the places that you need to fly because there is no infrastructure, or there is very difficult infrastructure for you to, in a sustainable manner. Okay. Thank you. Thank you. So yeah, please help yourself with, you know, with water, tea, coffee. We'll have lunch in a few minutes together. But you know, we are here for your questions. Anything that comes to your mind, and all guys are around.